NASA reports that its Voyager 1 probe, the most distant human-made object in the cosmos, is once again sending valuable information back to Earth. While we are still unsure of its exact nature, we can measure it. Voyager 1, the iconic space probe launched by NASA over 45 years ago, has transmitted a signal that has created a stir within the scientific community. After traveling nearly 14 billion miles from Earth, Voyager 1 has made a discovery so significant that it has changed the direction of its mission, turning back toward our planet. But what exactly could this discovery entail? Could it be evidence of extraterrestrial life, a cosmic anomaly, or something even more astonishing? In this riveting exploration, we will reveal these astonishing findings. Voyager 1 has just made a startling discovery that has prompted it to redirect its course toward Earth. The Voyager twin probes, if not for the alignment of certain celestial events, might never have departed Earth. Around 60 years ago, the 4 largest planets in our solar system were slowly aligning in a way last seen during Thomas Jefferson's presidency in the early 19th century. This rare planetary alignment initially went unnoticed. The first individual to recognize its significance was Gary Flandreau, a doctoral student in aeronautics at the California Institute of Technology in 1965. As space exploration was just beginning, Flandreau, working part-time at NASA's Jet Propulsion Laboratory in Pasadena, California, was tasked with determining the most efficient way to send a space probe to Jupiter or even further out to Saturn, Uranus, or Neptune. Using a simple pencil, he meticulously charted the orbital paths of these giant planets and made a fascinating discovery. In the late 1970s and early 1980s, all 4 planets would align in a way that would allow them to be visited in a single mission. This alignment meant that a spacecraft could use the gravitational pull of each planet to compel itself to the next, significantly reducing travel time. Flandreau calculated that this alignment would cut the flight time from Earth to Neptune from 30 years to just 12 years. However, this planetary alignment occurred only once every 176 years. To take advantage of this rare opportunity, a spacecraft would need to be launched by the mid-1970s. NASA seized this once-in-a-lifetime chance and built 2 spacecraft to undertake the journey. These spacecraft, Voyager 1 and Voyager 2, were launched on an extraordinary mission to explore the outer planets of our solar system. Thanks to the planetary alignment and Gary Flandreau's visionary calculations, the launch of the Voyager twin probes on September 5, 1977, was a historic event at Cape Canaveral in Florida. Voyager 1 embarked on its epic journey into space, propelled by a powerful rocket known as Titan 3E or Centaur, just 15 days after Voyager 2's launch on August 20, 1977. Voyager 1 began its cosmic adventure, starting its voyage into the vast universe by following a shorter trajectory. Their primary mission was to explore the massive gas giants in our solar system, such as Jupiter and Saturn, along with their numerous moons. However, these daring space travelers exceeded all expectations. They ventured far beyond, pushing the boundaries of exploration and traveling farther and longer than any other spacecraft in history. They set numerous records on their inspiring odyssey, journeying beyond anything created by humans before, even venturing into a region known as interstellar space, a completely uncharted territory within our galaxy. These pioneering spacecraft, Voyager 1 and Voyager 2, are now more than 12 billion miles away from us. Despite their immense distance, they continue to amaze scientists with the remarkable discoveries they make out there. Most recently, they made a discovery so unexpected that it took everyone by surprise. The Voyager twin probes have achieved some truly remarkable feats. Over 40 years ago, they examined the moons of Jupiter and Saturn, which were initially believed to be dull and pockmarked like our moon. These moons turned out to be vibrant hubs of activity. Voyager 2 made history by becoming the first of the twins to fly past Uranus in 1986, and just 3 years later, zipped past Neptune, an accomplishment unmatched by any other spacecraft. As these spacecraft continued their incredible journey, NASA employed clever strategies to ensure their operational longevity. They deactivated non-essential components, such as spare parts and heaters, to conserve power. This strategy aims to keep the spacecraft functioning smoothly until at least 2030. For the dedicated scientists and engineers who have been part of this extraordinary adventure from its inception, it is a bittersweet mix of emotions. Their hard work has paid off, and just when they thought the Voyager missions were nearing their end, a stunning discovery emerged from the depths of outer space. Decades ago, the Voyager spacecraft amazed researchers by providing the first close-up views of the moons of Jupiter and Saturn. These moons, which astronomers had thought to be dull and heavily cratered like our own moon, turned out to be vibrant worlds. Voyager 1 reached Jupiter in March 1979, just 546 days after its launch. Voyager 2, following a slightly different path, arrived in July of the same year. Both spacecraft were equipped with Vidicon cameras that used filters to capture full-color images. Interestingly, they were designed to be very stable, spinning through space at a rate more than 15 times slower than the hour hand of a clock, which ensured that the images they captured were clear and sharp. During their mission, the Voyagers took more than 33,000 photographs of Jupiter and its moons, each revealing new and fascinating details. For instance, Europa, one of Jupiter's 53 named moons, was found to have a cracked icy crust estimated to be more than 60 meters thick. As the spacecraft departed from the Jupiter system, they received a farewell boost in speed of 35,700 miles per hour from a gravitational slingshot, a crucial maneuver that helped propel them towards interstellar space. At Saturn, the Voyagers went their separate ways. Voyager 1 passed through Saturn's majestic rings, enduring thousands of impacts from tiny dust particles before flying past Titan, a moon enveloped in an orange haze, and heading northward out of the plane of the planets. Voyager 2 continued its solitary journey, reaching Uranus and Neptune in 1986. During its visit to Uranus, Voyager 2 discovered 10 new moons and added the planet to the list of worlds in our solar system with rings. However, Voyager 2's achievements were overshadowed by tragedy. Just 4 days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded shortly after liftoff, claiming the lives of all 7 crew members, including Krista McAuliffe, a high school teacher from New Hampshire who was set to become the first civilian to travel into space. 3 years later, as Voyager 2 ascended approximately 2,800 miles above Neptune's breathtaking blue methane atmosphere, it encountered the fastest winds ever recorded on any planet in our solar system, reaching velocities of up to 1,000 miles per hour. Neptune's largest moon, Triton, proved to be one of the coldest locations in our cosmic vicinity, with surface temperatures plunging to an astonishing -235 degrees Celsius. The moon's frozen volcanoes were another extraordinary finding, expelling nitrogen gas and fine particles up to 5 miles into its atmosphere. Following Voyager 2's captivating images of Neptune and its moons, both spacecraft were to deactivate their cameras, marking the end of their official mission. However, astronomer Carl Sagan, a member of the mission's imaging team, intervened. Although the grand tour was officially over, NASA extended the mission with hopes that the Voyagers would venture into interstellar space. Renamed the Voyager Interstellar Mission, the spacecraft were slated to continue their journey into the unknown. Sagan convinced NASA to allow Voyager 1 to take one final series of images. On February 14, 1990, the spacecraft redirected its cameras toward the inner solar system and captured 60 last photos. One of these images, famously termed by Sagan as the pale blue dot, showed Earth from an astonishing distance of 3.8 billion miles. In the photo, Earth appears as a tiny, barely discernible against the vastness of space, illuminated by a faint glint of sunlight reflected off the camera's lens. We have gained a tremendous amount of knowledge about the planets and moons in our solar system, and it's thrilling to observe how unique and intriguing each one is, even those that are the farthest away. Voyager 1's journey beyond the heliosphere in August 2012 marked a significant milestone. By moving beyond the heliosphere, a vast region of charged particles emitted by the Sun, Voyager 1's notable achievement became widely recognized the following year when a study was published in the journal Science detailing Voyager 1's groundbreaking discovery. The spacecraft's plasma wave instrument detected a powerful solar outburst between April 9 and May 22, 2013. This event caused electrons near Voyager 1 to oscillate, signaling that the spacecraft had entered a region of higher particle density than that found just inside the heliosphere. Initially, it might seem surprising that the electron density is greater in interstellar space than near the Sun. However, researchers clarified that the electron density at the edge of the heliosphere is significantly lower than at Earth's surface. By analyzing Voyager 1's data, researchers pinpointed the official departure date as August 25, 2012. This determination was based not only on electron oscillations but also on measurements of charged solar particles collected by the spacecraft on that notable day. Coincidentally, this was also the day that the famed Apollo 11 astronaut Neil Armstrong passed away. On this crucial date, Voyager 1 detected a remarkable thousandfold decrease in solar particles and a 9% increase in galactic cosmic rays originating from outside the solar system. This discovery served as a strong indicator that Voyager 1 had transitioned into a completely new and uncharted environment. Since then, it has continued to transmit valuable data from interstellar space. This presents a unique opportunity to study particles unaffected by the Sun, enhancing our understanding of this unexplored region of the universe. While its sister spacecraft, Voyager 2, made a similar crossing into interstellar space on November 5, 2018, Voyager 1 remains the more distant of the two. Currently, it is traveling away from us at a speed of over 35,000 miles per hour and is approximately 14 billion miles from Earth. Despite its vast distance, Voyager 1 continues to send back data to NASA. Because the communication time between Voyager 1 and Earth is more than 20 hours one way, the data is carefully analyzed and interpreted by the dedicated team at NASA. Although the mission's principal investigator, Edward Stone, believes the Voyager missions could last another 5 years, scientists are working hard to ensure that both spacecraft remain operational until 2030. What do you think? Will Voyager 1's next findings bring even more surprises? How will it impact our understanding of the universe? Please share your thoughts in the comments below.